In this video, we are going to learn how to find the n term of sequences with quadratic rule or quadratic sequence. A quadratic sequence is a sequence in which the nth term is quadratic. What do I mean by that? In our previous class, where we look at linear sequences, the nth term or the general term of such sequences is Tn equal to an plus b. This is a linear equation here. For a quadratic sequence, we will not have a linear equation like this. We're going to have a quadratic equation such that the n term of the sequence with quadratic rule is an squared plus bn plus c. So any sequence whose nth term or the general term follows this kind of quadratic pattern is called a quadratic sequence. Now, for such sequence, their first order difference are usually not the same. For us to get a constant difference, we need to take the second order differences. For example, let's look at this first one here, A, which is 1, 2, 4, 7, and 11. If we are taking the differences between the consecutive terms, we have something like this. Excuse me. Have 1, 2, 4, 7, 11, and so on and so forth. The difference between 1 and 2 is 1. The difference between 2 and 4 is 2. The difference between 4 and 7 is 3. And then the difference between 7 and 11 is 4. You can see that this first order difference are not the same because the sequence is quadratic. For us to get a second order difference, for us to get a constant difference, we need to take the second order difference. And let's do that. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. This is the second order difference. And we can see that it gives us a constant number. So a sequence like this is called quadratic sequence. Let's try that for B2 to get their differences, both the first order and the second order differences. So B, I have 4, 7, 12, 19, 28, dot, dot, dot. 7 minus 4 is 3. 12 minus 7 is 5. 19 minus 7 is 7. 19 minus 12 rather is 7. And 28 minus 19 is 9. You can see again that here the first order difference are not the same because the sequence is quadratic. For us to get a constant difference, we need to go to the second order difference. 5 minus 3 is 2. 7 minus 5 is 2. And 9 minus 7 is 2. So any sequence that behaves like this, whereby the first order difference is not a constant term, for us to get a constant term, we need to move to the second order difference. Such a sequence is a quadratic sequence. Now, how can we generate the nth term for a given sequence that is quadratic? We know that the general term for a quadratic sequence Tn or Un is an squared plus bn plus c. So, like the first sequence we had there, which is, let me clean this board so I have space to work with. The first sequence, which is 1, 2, 4, 7, and 11. Again, let's take their differences, both the first order difference and the second order difference. For the first order difference, I have, let me write the sequence first. 1, that's 8, yeah. 1, 2, 4, 7, 11, and so on and so forth. The first order difference, 2 minus 1 is 1, 4 minus 2 is 2, 7 minus 4 is 3, 11 minus 4, and minus 7, rather, is 4. Now, the second order difference, let's do that again. 2 minus 1, 1, 3 minus 2, 1, 4 minus 3, 1. Now, we do the same thing for this nth term. What do I mean? What if I substitute 1, 2, 3, 1, 2, 3, 4, and so on and so forth into this equation Tn equal to an squared plus bn plus c. I will generate the terms of this sequence with several unknown. So let me do that in a tabular form here. I have n, which is the nth term. I even supposed to have a table for this side too. Sorry, let's do a table so that it will be clearer for us. Let me do a table for this sequence A first so that I can compare. So for the sequence A, I have n and then the term of the sequence. When n is 1, what is a sequence? The term then is also 1. When n is 2, the term is 2. When n is 3, the term is 4. When n is 4, the term is 7. And when n is 5, the term is 11. So taking their differences now, 2 minus 1 is 1, 4 minus 2 is 2, 7 minus 4 is 3, and 11 minus 7 is 4. That is the first order difference. Now for the second order difference, we have 2 minus 1 is 1, 3 minus 2 is 1, and 4 minus 3 is also 1. That is the second order difference. So now putting n equal to 1, 2, 3, 4. Okay, let me add one more since I have up to 5 terms in the sequence. If I put n equal to 1, 2, 3, 4, and 5 into this very formula here, I will get another table like this. So n and then term. When n is equal to 1, if I put n equal to 1 here, that is 1 times a, which is a. And n equal to 1 here, that is 1 times b, which is b. So when n is equal to 1, I'll have a plus b plus c. A plus b plus c as the term of the sequence when n is equal to 1. Again, when n is equal to 2, if I put here, 2 squared is 4. 4 times a is 4a. And then 2 times b is 2b. Then plus c. That is the second term of the sequence when n is equal to 2. When n is equal to 3, if I put 3 here, 3 squared is 9. 9 times A is 9A. Put 3 here, 3 times B is 3B. Put 3, okay, that is plus the constant term, C. What about when n is equal to 4? 4 squared is 16. 16 times A is 16A. I have 16A plus 4 times B is 4B plus then the constant term C. That is for n equal to 4. What about if n is equal to 5? I put 5 here. 5 squared is 25. 25 times A is 25A. 25A plus, let me rewrite the formula here since I can't see it there now. So AN squared plus BN plus C. Okay, so we had 5. 5 squared give us 25. 25 times A is 25A. Then if we put 5 here, that is 5 times B, which is 5B. Then plus C. These are the terms of this sequence for n equal to 1, 2, 3 down to 5. And let's get their differences. If we subtract these from this, C minus C will be gone. 0, 2B minus 1B is 1B. And 4A minus A is 3A. So here we have 3A plus 1B. Again, if I subtract this, C minus C is 0, 3B minus 2B is B, 9A minus 4A is 5A. I have 5A plus B. And subtract here again, C minus C is 0, 4B minus 3B, 1B, 16A minus 9A, that is 7A. I have 7A plus B. Then I subtract this again. C minus is 0. 25, 5B minus 4B rather is 1B. And 25 minus 16. 25A minus 16A is 9A. I have 9A plus B. That is the first order difference. Now let's take the second order difference. This minus this. B minus B is 0. 5A minus 3A is 2A. Then this and this subtracted from each other is 2A. This and this subtracted from each other is 2A. Okay, so this is the second order difference, which is now a constant. So if we compare the two tables, this table here and this table here, in terms of their row, this row here corresponds to this. That means 2A is equal to 1. 2A is equal to 1, which implies that A is equal to 1 over 2. That is when I divide both sides by 2. Now, if I compare the second row, I'm counting from the last one. So this row is my second row. If I compare that, 3A plus B correspond to 1, 5A plus B correspond to 2, 7A plus B correspond to 3, and 9A plus B correspond to 4. Using that information, we can get the value of B. Okay, so you can take any of this and equate it to the corresponding element in the first table. So I'm taking the first one here, 3A plus B, which corresponds to 1. So 3A plus B equal to 1. And we've known A to be 1, 1 over 2 rather. That means 3 times 1 over 2 plus B is equal to 1. I open this bracket, that is 3 over 2 plus b equal to 1. This is a fraction here. If I solve the fraction, LCM of 2 and 1 is 2. So I'll have 3 plus 2b over 2 equal to 1, which implies 3 plus 2b is equal to 2, and then 2b therefore is equal to 2 minus 3, and 2b rather is equal to minus 1. B therefore is minus 1 over 2. Okay, now we know the value of A and B. We need to find the value of C. For us to get the value of C, we compare this rule now, this very rule with this very rule. So here, A plus B plus C correspond to 1. 4A plus 2B plus C correspond to 2. 9A plus 3B plus C correspond to 4, and so on and so forth. So I will pick any one and then equate them. I'm picking the first one, A plus B plus C, which is 1. So A plus B plus C equal to 1. Now A is 1 over 2, and B is minus 1 over 2, while C is what we're looking for, so equal to 1. 1 over 2 minus 1 over 2 is 0, therefore C is equal to 1. Therefore, the general term for this sequence Tn, which is an squared plus bn plus c, now becomes A is half, so I have half n squared plus b is, okay, b is minus 1 over 2, so let me remove this plus here. The b is minus 1 over 2 n plus c, which is 1. That is the nth term of this sequence. Sequence number, what is the sequence? That's 1, where is it? 1, 2, 4, 7, and 11. Okay, now let's go on with the remaining one. Let me copy this and move it down. Okay, so the second one is 4, 7, 12, 19, and 28. Let's get the differences in a tabular form again. The nth term and the sequence is 4, 7, 12, 19, and 28. N is the first term there, that's 4. This is the second term. This is the third term. This is the fourth term. And this is the fifth term. So we're getting their differences. 7 minus 4 is 3. 12 minus 7 is 5. 19 minus 12 is 7. 28 minus 19 is 9. That is the first order difference. Let's go on to the second order difference. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. Okay, now we'll prepare another table for the nth term. Remember, the nth term is Tn equal to an squared plus bn plus c. Now let's substitute the value of n equal to 1, 2, 3, 4, and 5 into this formula here. So we generate another term of a sequence to n and then terms. When n is equal to 1, if I put 1 here, 1 square is 1. 1 times a is a. I put 1 here, 1 times b is b. So the term of the sequence becomes a plus b plus c. And if I put n equal to 2, 2 square is 4. 4 times a is 4a. Then I put 2 times b is 2b plus c. That is for n equal to 2. What about n equal to 3? 3 square is 9. 9 times a is 9a plus 3b plus c. And then when n is 4, 4 square is 16. 16 times a is 16a plus 4b plus c. I'm just putting the value into this equation here. So let's take the last one, which is n equal to 5. N equal to 5. 5 square is 25 times a is 25a. 25a plus 5b plus c. That is the fifth term of the sequence. Again, let's take their differences. If I subtract a plus b plus c from 4a plus 2b plus c, of course c will be 0, c minus c 0, 2b minus b is b, 4a minus a is 3a. I have 3a plus b. Here if I subtract here, 9a minus 4a is 5a, 5a plus 3b minus 2b is b, and c minus c 0. Subtract this from this. 16a minus 9 is 7a. 4b minus 3b is b. And here 25a minus 16a is 9a. 5b minus 4b is 1b. Okay, so that is the first order differences. Taking the second order differences. 5a minus 3a is 2a. b minus b is 0. Again here, I have 2a again. And here, I also have 2a. Now we have a constant differences. Now if you compare the two tables, 2a here, as in the whole of this row, correspond to this row here. And this row of element correspond to this row of element there. This row of element correspond to this row of element there. So if you compare them, 2a is equal to 2. 2a is equal to 2. That means a is equal to 2 divided by 2, which is 1. Now correspondingly, comparing rather, this second row now, in that case, 3a plus b correspond to 3 here. 5a plus b correspond to 5 here. 7a plus b correspond to 7 there. And then 9a plus b correspond to 9 here. So let's equate any of them. I'm equating the first one, that is 3a plus b, which is, okay, let me use the second one. Because any one we use, we are going to arrive at the same answer. 5a plus b correspond to 5 there. So 5a plus b equal to 5. Now solving for b, we know that a is 1. That is 5 times 1 plus b equal to 5. 5 times 1 is of course 5 plus b equal to 5. That means b is equal to 5 minus 5, which is 0. Now let's solve for c. To do that, we compare the first row in table 1 and table 2. So in this case, a plus b plus c correspond to 4 because both of them are in first position. 4a plus 2b plus c correspond to 7. 9a plus 3b plus c correspond to 12, and so on and so forth. So let me pick the first one, a plus b plus c, which is equal to 4. A plus b plus c equal to 4. We know a to be 1, b 0, and c then equal to 4. That means c is equal to 4 minus 1. C is equal to 3 is the value there. And then we say that Tn is equal to an squared plus bn plus c. So we've known a to be 1. So that is n squared plus b is 0. So 0 times n is 0. So I don't need to write that. Yc is 3. So the nth term, or the general term of this sequence is n squared plus 3. Let me test it whether it agrees with the sequence. The sequence is 4, 7, 12, 19, and 28. So when n is equal to 1, by putting 1 there, 1 squared is 1. 1 plus 1 is 4. What about if n is equal to 2? If n is equal to 2, what is the sequence? The sequence is, the term rather, is 7. Let's see whether we get 7. 2 squared plus 3. 2 squared is 4. 4 plus 3 is 7. Let me check it for the last term, 28. Let's check it. And 28 is in position 5. So n equal to 5. If n is equal to 5, we have 5 squared plus 3. 5 squared is 25. 25 plus 3 is 28. That means this formula is correct. Tn equal to n squared plus 3 is the nth term of that sequence. Now let's move on to the next one. Let me repeat the question here again. Here we have the third one is 1 minus 4 minus 50 minus 32 minus 55, and so on and so forth. I have question C. Again, let me prepare my table here. And then the terms. When n is 1, the term there is 1. When n is 2, the term there is 4. When n is 3, the term there is minus 15. When n is 4, the term there is minus 32. When n is 5, the term there is minus 55. Now taking their differences, minus 4 minus 1 is minus 5. And minus 15 minus 4. Look at, there is 2 minus there. I have minus 15. And I want to subtract minus 4 from it. That is minus 15. Minus is plus 4. So minus 15 plus 4 is minus 11. And then taking the difference between this again, that is minus 32 minus minus 15. That is minus 32 plus 15, which gives us minus 17. Minus 17. And then minus 55 minus 32. That is minus 55 plus 32, which gives us minus 23. Here is my, okay, I've written that already. Let me remove this. Minus 23. 23. That is the first order difference. Let me take the second order difference. That is, subtracting this from each other, we have minus 11 minus 5. And that gives us minus 6. This and this also is minus 6. This and this also is minus 6. Okay, that is the first table there. Let me remove this, I have space. Now let's get the second table in terms of the formula Tn equal to an squared plus bn plus c. So if I put in the value of n to be 1, 2, 3, 4, and 5, that will give me another sequence like this. When n is 1, if I put 1 into this formula, I will have a plus b plus c. When n is 2, if I put 2 here, 2 squared is 4. So I'll have 4a plus 2b plus c. If I put n equal to 3 there, I will have 3 squared is 9. So 9a plus 3b plus c. And then, what about if n is 4? 4 squared is 16. I have 16a plus 4b plus c. And then lastly, when n is 5, 5 squared is 25. 25 times a is 25a plus 5b plus c. Again, let's take their differences. When we subtract this from this, we have 3a plus b. If I subtract this from this, I will have 5a plus b. Again, I subtract this, and we have 7a plus b. Subtract this, I wrote 2a here instead of 25. It's supposed to be 25, not 2a. So 25a, what is wrong? 25a plus 5b plus c. That's what it's supposed to be there. So when I subtract them, I will have 9a plus b. Okay, that's the first order difference. Let's take the second order difference. This minus this is 2a, and this is also 2a. When we subtract this, we also have 2a. So the second order difference, comparing the rows in table 1 to rows in table 2. This last row here corresponds to the last row there. The second row corresponds to the second row there. The first row corresponds to the first row there. That means starting with the last row, 2a is equal to minus 6. 2a is equal to minus 6. That means dividing both sides by 2, a is equal to minus 6 over 2, which is minus 3. Okay, now we need to find the value of b. To do that, we compare the element in the second row of table 1 with element in the second row of table 2. So here, 3a plus b correspond to minus 5 here. 5a plus b correspond to minus 11. 7a plus b correspond to minus 17. And 9a plus b correspond to minus 23. I'll say it goes like that. So let's take the first one, 3a plus b, which is minus 5. 3a plus b is equal to minus 5. And we know a to be minus 3. That means 3 times minus 3 plus b is equal to minus 5. 3 times minus 3 is minus 9 plus b equal to minus 5. Okay, that means taking minus 5 to the other side. That is minus 5 plus 9. And b therefore is 4. Minus 5 plus 9 is 4. Now let's solve for c. For c, I will compare this element here, a plus b plus c, which is corresponding to 1 here, or 4a plus 2b plus c corresponding to minus 4 there. Okay, let me take a plus b plus c equal to 1. Now a is minus 3, b is 4, and c is what we are looking for. Minus 3 plus 4 is 1. The 1 plus c equal to 1. C therefore is 1 minus 1, which is 0. Okay, we know the value of all the constant term. Remember, Tn is equal to an squared plus bn plus c. So Tn therefore, a is minus 3, 3n squared, b is 4, and c is 0. So the n term of this sequence is minus 3n squared plus 4n. Let's test it with the sequence. So that will get the terms of this sequence. The first term is 1. That is for when n is equal to 1. So if n is equal to 1, putting in 1 here, I have 1 squared is 1. Okay, let me even write it. Minus 3 times 1 squared plus 4 times 1, which is minus 3. 1 squared is 1 times minus 3 is minus 3. And 4 times 1 is 4. Minus 3 plus 4 is 1. Of course, it agrees with the first term of the sequence, which is 1. Then let's check with second term. When n is equal to 2, that is 3 minus 3 rather, times 2 squared plus 4 times 2. 2 squared is 4. 4 times minus 3 is minus 12. Then 4 times 2 is 8. Minus 12 plus 8 is minus 4. It agrees with the second term again, which is minus 4 there. Let's check with the third term, the last one. When n is equal to 3, that will be, what is the formula? Minus 3 times 3 squared plus 4 times 3, which is minus 3 times 9 plus 12. 3 times 9 is 27. That's minus 27 there, plus 12. Of course, that gives us minus 15. Does he agree with that? Minus 15, yes, that is the term. That means the formula Tn equal to minus 3n squared plus 4n is correct for that sequence. Let's move on to the last one. Sorry about that. Okay, for the last one, I have 0, 7, 18, 33, and 52. So again, I'll prepare my table here, n, and then the term of the sequence. When n is 1, the term there is 0, the term there is 7, the term is 18, term is 33, the term is 52. Taking their first order differences, 7 minus 0 is 7, 18 minus 7 is 11, 33 minus 18 is 15, and 52 minus 33 is 19. That is the first order difference. The second order difference, 11 minus 7 is 4, 15 minus 11 is again 4, 19 minus 15 is again 4. Now let's prepare another table for the nth term. Say that Tn is equal to an squared plus bn plus c for any quadratic sequence. What if we put in the value n equal to 1, 2, 3, 4, and 5? We'll generate another table. Let me do it here. I want to manage this space. When n is 1, if I put 1 here, 1 squared is 1, times a is a. So I have 1 times b is b plus c. That is the first term of the sequence. If n is 2, 2 squared there is 4, 4 times a is 4a, then 2b and c. That is the second term of the sequence. Again, if I put n equal to 3, 3 squared is 9, times a is 9a, plus 3 times b is 3b, and then c. The third term, what about if n is 4, 4 squared 16, 16 times a, 16a, plus 4b, and c, plus c. And the last term, 5. 5 squared is 25, 25a, I have 25a plus 5b plus c. Let's get their differences. If we subtract this from this, we have 3a plus b. Subtract this from this, we have 5a plus b. Subtract this from this, we have 7a plus b. Okay, we subtract this from this, 9a plus b. That is the first order difference. Taking the second order difference, we have 2a there, 2a, 2a. Okay, now let's compare the tables. The last row here corresponds to 4, 4, 4. The last row there. This corresponds to this, and then this corresponds to this. That means 2a is equal to 4. 2a is equal to 4. Divide both sides by 2. A is equal to 2. Comparing now the element of the second row, 3a plus b corresponds to 7. 5a plus b corresponds to 11. 7a plus b corresponds to 15, and so on and so forth. Let me use that 7a plus b equal to 15. Whichever one you use, you are going to get the same thing. So I'm comparing the third element in each table. 1, 2, 3 is to 1, 2, 3. So 15, 7a plus b equal to 15. And we know a to be 2. That is 7 times 2 plus b is equal to 15. That is 14 plus b is equal to 15. B therefore is 15 minus 14, which is 1. Okay, now let's get the last term, which is c. Here we compare the element of the first row in table 1 to the element of the first row in table 2. That means a plus b plus c is equal to 0. 4a plus 2b plus c equal to 7. Let me use that. 4a plus 2b plus c equal to 7. We know a to be 2, so 4 times 2, b is 1, plus c equal to 0. 4 times 2 is 8, and 2 times 1 is 2, c equal to 0. 8 plus 2 is 10. 10 plus c equal to 7. C therefore is 7 minus 10. C equal to minus 3. So now that we know the value of a, b, and c, remember that Tn is equal to an squared plus bn plus c. A is 2, 10 times n squared. B is 1, so I have 1 times n is n, and c is minus 3. So minus 3 there. Tn is equal to that, and that is the nth term of this sequence. Let's check it whether it will agree with the sequence. The sequence is 0, 7, 18, and so on and so forth. So if n is equal to 1, if I put 1 there, that is 2 times 1 squared plus 1 minus 3. 2 times 1 squared is 1 times 2 is 2. 2 plus 1 minus 3 is of course 0. 2 plus 1 is 3. 3 minus 3 is 0. That I agree with the first term. Let's check it with the second term, whether we get 7. That is n equal to 2. And then putting it here, I have 2 times 2 squared plus 2 minus 3. 2 squared is 4. 4 times 2 is 8. Plus 2, minus 3. Minus 3. 8 plus 2 is 10. 10 minus 3 is 7. That means the formula Tn is what equal to 2n squared plus n minus 3 is correct for that sequence. And I hope that is the last one, right? Yes. That is how to generate a general term or an nth term of a quadratic sequence. That is what I have for you in this lesson. I hope you find it useful. If you do, don't forget to subscribe to my channel.